Okay, so I'll just kind of let my PowerPoint go through, and then I have a little video at the end, and I'll be happy to answer any questions that anybody has. But my project is called Glinda, which, as you can see, stands for Grab, Lift, Extend, Navigate, Deposit, and Arrange. And essentially, it is a method of attaching an articulated robot to a wheelchair to increase the reach and independence of people who have disabilities. Here's a quick little diagram of it, and then a small little explanation. My idea was to make it small and lightweight and easy to rotate into different orientations so that it can accommodate right and left-handed individuals. And when it's fully retracted, it sits about at the same height as the average person's head so that it doesn't cause any problems, with clearance as you try to go through a door or anything like that. And so as part of, our capstone project, we had to talk to people who might have a use for this, which for me meant finding individuals with disabilities and talking to them about it. It felt really awkward at first, trying to approach people about this, but everybody seemed really, really interested in hearing what I had to say. I had heard some really great stories from people, and almost everybody that I spoke to seemed really excited at this idea. The one person I didn't get a positive yes from was very much an athletic individual. I suspect he played a lot of basketball, and he had a pretty minimalistic wheelchair. So that's kind of the one wheelchair that I couldn't really attach this to. And I talked about my prototype is made out of wood and metal. I had to use what I had available, but the production model would be 3D printed, and it would be even cheaper, easier to make, much more lightweight, and it can be engineered with different size DC motors, different articulated robots that can have different payloads, higher reaches, even finer movements if we wanted to spend money on a more expensive controller. But the idea was that we can really make this as customizable as possible without really having to change the design that much. So here is the circuit that I'm using to run this, and I have a quick little video, and I'll just kind of let the video play. Let me see what's going on inside there. There we go. So this is my prototype. I've taken it apart so you can kind of see what's going on inside there. It's got a 12-volt power supply running a 12-volt battery. Currently this takes 5 volts, and I have it just hooked up to its own power supply. But the finished model would probably have actually a 24-volt rated motor, and then I would drop 5 volts off of that through a voltage divider off of a 24-volt battery. Because right now, as I'll show you in a minute, this battery or this motor is a little underpowered. But essentially, what happens is we've got these limit switches set up, and for the demo, I only have them right here. But of course, for the production model, they would be at the extreme ends. And essentially, the idea is with our 3-way limit switch, which would be attached to one cable that they can put on either side. We can raise and lower it up and down, and when it hits that limit switch, you can see the circuit in the PowerPoint that I have. Essentially, these 2 limit switches have the commons jump together through diodes in the reverse bias position, which really keeps the open limit switch connected, but because of that diode, it prevents current from flowing, and so the limit switch still, of course, functions. But this allows us to back it off again, as you'll see here. So it hits the limit switch, and thankfully then we can just back it right off. And so the idea is that this will sit on the back of the wheelchair, and this would then be right about here. And with this, we can raise and lower it, and the platform itself will be just below, about at the wrist. So we're kind of reaching the outer limit of what an individual in a wheelchair would be able to reach themselves. But then, at that upper limit, they can begin motion from our new articulated robot. And so the idea is that this should hopefully add a little bit of reach and a little more independence to people who have to use a wheelchair. That's the hope anyway. And I've talked to 10 people. 9 out of 10 people said that this was something they would definitely want to look into. The 10th person who wasn't interested in it was very much an athletic individual, and he had one of those minimalistic wheelchairs, which I wouldn't even really be able to attach this to. So that's kind of the only model of wheelchair I've found that I couldn't make this work on. Whether it's a standard wheelchair or one of the larger ones that you find in the hospitals, this should be able to work. And my hope is that this can make life easier for the individuals who have to use it, as well as the support staff who are around to help them. You know, anybody who can do things on their own, the more we can do, the better. You know, we really want to achieve independence and mobility, and that's one of the great benefits of automation, is that things like this can happen. So really, my whole design here is just a method for attaching this device to a wheelchair and then allowing it to be raised and lowered. At the end of it there, it's just an articulated robot. The models I'm looking at are about $500 because they have nice interpolated motion, so that you can be really fine and precise with your movements, because that's necessary if we're grabbing coffee cups or something fragile or something small. And those models tend to run off of 12 volts, so I may have to step up with like a 24 volt and then in series with another 12 volt to give us a total of 36 volts to work with, so that I can tap that 12 volts off for the robot itself, leaving the 24 volts for the DC motor so that it can go up and down a lot faster than I currently have it. And I want to make all of those in series. I don't want to have 2 separate batteries with 2 separate charge ports, because I want to make the whole thing user-friendly. And so that's why I would run the 12 volts off of a voltage divider, and I would put those 2 batteries in series. But essentially, this is what I've been working on. I had to come up with a new design using this rail and an outside teeth. And the point of this is to prevent everything from rotating, as this all-thread shaft rotates and drives the whole mechanism up and down. My initial plan was to just have a crossbar with a fixed piece of PVC, and then this can move up and down. You know, this would be attached to a piece of PVC on the outer edge that's allowed to freely move, but it would keep the whole thing steady. And I ultimately want to go back to that design because it keeps the center of gravity shifted. As you can see, with everything off on one side, it wants to pull, and it kind of has a little bit of trouble with a small bit of rotation that's still allowed. There's some pretty loose allowances in this whole design. And so I would tighten all that up. The only reason I did it this way is because the small local hardware store that I have access to didn't have a lot of PVC. So I had to improvise and come up with a new solution. I would also not use all thread. I would probably print something that's closer to like a 5-to-1 ratio. I believe that this all thread's at 15-to-1. So if we were using this, and you can see how, if you're waiting to raise and lower this, like, it's going to take a minute, and that's not ideal. So that's something that I would change between this prototype and the production model. The added benefit of that as well is that it reduces the weight of everything. So that's my capstone project. I call her Glenda, which stands for grab, lift, extend, navigate, deposit, and arrange, because hopefully that's what Glenda will allow you to do. So thank you very much.
Thank you all. Sorry again about the technical difficulties there. And then as my final slide, I thought it was worthwhile to kind of look at what already exists. And Canova Robotics makes this product called the Jocko. And this thing is so amazing. It's really doing exactly what I'm trying to do, but it has a lot of power needs. And so it can only be attached to power wheelchairs, and it's pretty expensive. And so there's a hole in the market that I hope my product would be able to fill. So thank you all very much. I appreciate it. Yeah, that model actually does have a PlayStation controller. You know, that's pretty cool. And I like the idea of having remote control, but I ultimately want to keep something that is affixed to the unit itself via cables so that it doesn't get lost, because that would suck. I saw there was a question about how many pounds it can hold. That model can hold 200 kilograms, or no, 200 grams, excuse me. That one doesn't have a very high payload. The payload really does depend on the model of robot you use. Ultimately, that comes down to how powerful are your servo motors, and more powerful servo motors need more power to supply them. So it's never going to be ideal for doing any heavy lifting. I wanted to focus on the smaller, precise movements, things like opening cabinets and grabbing cups, things that are higher up. So if you're able to pull open a fridge door, I think that would be kind of the goal for me, as far as like the hardest use would be being able to actually access and open a fridge. Nobody's actually tested this one for a day. It never really went off of my counter, unfortunately, because this model is such a loose built prototype that you know, with having to cut everything by hand with a skill saw, it was never really quite there. But I did have a wheelchair available, so I was able to test and make sure that everything sat at the right height and that it didn't add so much weight that it pulled, you know, the center of balance off of a person who's using the wheelchair, because that would be a really big concern is if, you know, this thing can tip the wheelchair, which is something, of course, we want to avoid, which is another reason I would want to limit, you know, any of that heavy lifting. So I think that was all the questions I saw. I really appreciate everybody giving me a chance to present that. Thank you so much.
Thank you so much for joining us and having that presentation ready for us as well. Okay, John, do you want to go ahead and introduce Richard?
Sure. Richard has been working with 3D printers in remote. Richard has really been excited about what he's been doing, and he's worked online with some other engineers in the same area, getting ideas and seeing what they think of his ideas. Richard, go ahead.
Okay, so my project was to create a system that used a control system, a separated computer that allows for automated 3D printing from auxiliary locations. Actually, I want to thank Max. He was my buddy in Texas that actually sent a print file at the end. I'll show the video of a print file that came from Texas to Washington. Real quick, I want to go over some common nomenclature that goes with 3D printing. So we have 3D FDM, that's fused deposition modeling in the third dimension. The bed is the print surface. The nozzle is going to be the heated component that extrudes the material, usually plastics. The UI is going to be the user interface. Most people are familiar with Windows or Mac OS. Linux, which is an open source lightweight UI. Raspberry Pi, a small form factor PC. Let's see, filament is going to be an extruded material that is the print material, mostly plastics, the most common being polylactic acid. Time-lapse is a video produced from still images. USB to micro USB cable used to transmit data from Raspberry Pi to the SnapMaker. G Code, which is a type of computer numerical control programming language used to control a machine. CNC, laser engraving, most of those use G Code. And then Marlin G Code, which is a flavor or type of G Code that is very popular in the 3D printing community. And so what I did was I used what's called a SnapMaker 2.0 A350, which is a multifunction CNC laser engraver and 3D printer. And then I paired it with a Raspberry Pi, which is a small form factor PC, combined with a Raspberry Pi CAM version 2 and a 32 gigabyte SD card to hold the user interface. I then installed Octoprint UI, which is specifically built by open source engineers just on their spare time for free to connect your 3D printer to an online platform. That way you can leave your house and not have to worry about your prints failing and burning your whole house down. So it also provides functions like shutdown, start and stopping printing, progress of the print, code errors if there's something that you loaded on accident, monitoring of the system, the temperature of the nozzle, the bed. It allows for an automatic time lapse automatically after the print is finished. And then it also allows you to control it. So for example, if you're printing something and the nozzle skips a bead, it goes, say, it's supposed to go only about 0.2 millimeters per layer. If it accidentally skips 0.4, you can go in through Octoprint and lower the nozzle so you don't completely ruin a print. You can also turn up the temperature if you needed to change it. And then I used a application on the Octoprint platform called Octo Anywhere, which is actually what Max signed into to allow him to access my Raspberry Pi in Washington. And then Spaghetti Detective was an application that I used as well. It's supposed to allow for automated ending of prints in case of error or failed prints, and then it sends you a text message. I couldn't get it to work because the camera wouldn't focus, and to change the focus of the camera, I have to get into the physical code structure of the Octoprint, and every time I did it, it bricked it. So that didn't work out. And then I combined it with what's called a filament dryer. It's a small contained oven that the filament sits in, and it allows it to keep the moisture out of the environment, because when filament is exposed to moisture, it ruins your prints. It can cause, it's called wet filament, and it'll just destroy a print. It causes bubbling and all kinds of nasty layers. And so I was able to successfully get prints to run. I was unsuccessful in getting the automated error checking that I wished to get. And so the marketability on this was, and I had talked to actually a couple of engineers who have the same system as I did. The only problem is that if they were going to buy my system and pay the $160 that I was asking for the product, they wanted to make sure that it had some included features like a filament runout sensor, which if your filament runs out, it stops the print, sends you a text saying, hey, you're out of filament, go ahead and load me up and I'll continue. And then automatic power loss recovery in case of power outages, which is another major component that people love in 3D printing. And so with that, I'm going to go ahead and share the, sorry if I'm going a little fast, but I'm going to go ahead and show the auxiliary print that I sent. It has no audio, so. And this is a 3D fidget spinner file that I found on Thingiverse, and it's a very popular file because of how easy it is to print. Just a little quick 16 seconds. And so as you can see on the left side, there's the filament oven, and then you've got what's called Bowden tubing running between the dryer and the print head, not allowing any moisture to actually gap inside of it and create bubbles. This print actually turned out amazing. There was no problems. It didn't cause any errors, which I'm really quite proud of actually. And so that's basically what I did with mine. Like I said, sorry if I was a little fast. I just don't want to take over anybody's time. So if there's any questions, I'm ready for them.
Thank you so much, Richard. We're so glad you could join us today. Questions for Richard?
I do not actually have the example on me. I currently have all of my goods in storage, so I don't have the fidget spinner on hand. I actually gave it to my old roommate. Throughout the quarter, I was actually printing a bunch of these. It was my test file that I used. So almost all of my roommates down in Centralia now have one. I just don't have one on me. But it was, it's really cool actually, because the entire print required no what's called supports, which hold the structure up in case so that it doesn't fail. And it all printed as one piece. And then when you lift it up, you literally just kind of cracks, and then the whole thing spins, and it almost reminds me of like any movie where there's like a time machine. You see all the spinning dials on inside of each other, and it did that basically. So any other questions?
Couple of additional questions for you there.
Yeah, so I am actually going to be working on an electrical engineering degree through Tacoma Community and UW-Tacoma. And so I will be furthering this product because I want to make the functions fully available. And actually, I want to make this open source as well. I don't want to charge for it personally. The plastics are not compostable. A lot of people will say they are not. The PLA, polylactic acid, is actually extracted from corn husks, but it just doesn't break down. It's one of those things that you put it in the ocean, it's going to float around and break into microparticulates. There are some people that are trying to get in the field of creating those, but they're having some mixed results because it's really hard to get the temperature right and the layers right. So